he's also SolidWorks customer #1, the first order we ever got for SolidWorks. Please join me in welcoming from Barrett Technology, the founder and CEO, Dr. Bill Townsend. Welcome to SolidWorks World, Bill.
Thank you. Wow. There's more than one user now.
Yeah, there's more than one user, right. I mean, Bill and I, back in the day, we could have had SolidWorks World. I mean, we could have just gone for lunch together.
That's right.
That would have been the whole thing right there.
And I understand you just hit 1 million users recently.
Oh, yeah. Well, yeah, we have over 1 million SolidWorks users now. Thank you all. I mean, it's you guys that do it, you know.
The other 900, this is 5,000 seating capacity, right?
Right.
The other 995,000 showed up. It doubled the population of San Antonio.
Oh, yeah, that's true. We might have more SolidWorks users that would fit in the city. That would be a nice problem. Bill, thanks for being customer #1, but beyond just giving us the order for SolidWorks, Bill gave us a whole lot more. Because when I was originally thinking about the plan for SolidWorks, yeah, there's the actual order.
Net 120.
But before we ever took any orders, when I was deciding whether or not to start the company, shouldn't I start it, I went to Bill for advice. He was my friend and advisor, and he gave me encouragement. He said, John, go do this thing. And I got to tell you, without his advice and support and encouragement, we all might not be here today. So thank you, Bill, again. Okay, that was great.
I don't know what you're thanking me for, but I should be thanking you, I think.
Okay. Well, anyway, it's been great. So, Bill, there were lots of robots in the world for many years. Lots of old robots existed before you started Barrett Technology, right?
Yep.
Okay, so why start Barrett? Why build new robots?
Right. Well, we wanted to have robots that worked around people. Before we came along, there was sort of what we call robotics 1.0, which is robots that go from point A to point B to point A to point B, and do that for 5 years. We wanted to go beyond that. These robots that go from point A to point B were very dangerous around people, and the rule was to segregate the people from the robot. And, it didn't make sense. If you were going to look into the future and there was going to be, like, for example, robotic surgery, how do you separate the robot from the person and do robotic surgery? So we call that robotics 2.0, and that's I think starting to come into its own.
And we actually have video here, like starting with the handshake.
Yeah.
These are Bill's robots from Barrett Technology, robotic arms.
Right, and so those aren't pre-programmed. The handshake is not pre-programmed. It's just following the forces of the handshake.
Yeah, I think that's iconic of working with.
Yes.
Working with humans.
And they're getting force feedback as they do this task. They can feel the very gentle torques as they're grabbing this bag and opening it and manipulating it.
Now, in the real world, they might be looking for something other than a flashlight.
Yes.
And but
you can tell by the military garb.
It's amazing the way you work with soft objects. I've seen Bill's robots unzip a zipper.
Yes.
Look at this.
So it's following a path, a trajectory at the end point, and doesn't know those people are going to show up. There goes the warranty.
No warranty left out. But again, it's amazing also, having been around Bill's robots a bit, not only are they human-friendly when they touch you, but when you touch the robot, it's just really cool. You grab the robot, it's like grabbing someone's arm.
That's right.
And so what kinds of technology did he have to build in order to get that to happen?
Well, we build gearless drives. So robots today, all robots other than ours, use some form of either gear or harmonic drive, which is a form of a gear. And we don't. We use gearless by using cables, aircraft cables. We get extraordinarily smooth torque, which is something that we need in order to do this force feedback that we have with people.
And no gears.
And no gears.
No gears. And you also have like virtually no backlash.
That's right. So
Friction,
the backlash is gone. The friction is very low. Really nice mechanical drives, you know, it's really made our products work well.
And so on the mechanical drives, you pioneered the cable drive system. Now on the electrical side, I know you had some tough wiring problems, right?
We did. Wiring, someone once asked me, this is about 15 years ago, what is the hardest part about designing a robotic arm? And I said, the wiring. And I know a lot of customers tell me the same thing in their own machine designs, their own products, right? The wiring can be a really tough problem. It can be a tough problem.
And so how many wires did you have running into the robot?
We had roughly 100 wires going into the base of the robot to service 7 motors.
And those wires come from the big controller cabinet.
That's right. It comes from the big controller cabinet and things about the size of a refrigerator. And, you know, it's just massive.
Yeah, something most of you would be familiar with. A big cabinet of motor control electronics. And how did you solve this problem, the wires?
Well, it was sort of by mistake. You know, it's like a lot of inventions. It started out with, we were trying to get smoother torque, and these motor controllers did not give us the smoothness that we needed. And it turns out, and we just got a patent on this 2 weeks ago, it turns out that if you make the controller really small, keep the distances very short between components, that the torque becomes very, very smooth and very important to us. So by making it small, all of the components that normally are there, our invention gets rid of a lot of components. So we're able to make it small, but we needed to use SolidWorks in order to nest the components
Now
together.
wait, when you say small, you took the refrigerator-sized box of motor electronics. How small did you make it?
Well, I brought one with me. I by mistake, carried this through airport security.
Well, that must have been interesting.
Yeah, and they never stopped me. It looks like a coin.
So this is what you call the puck, right?
This is what we call the puck.
Now what's in there, Bill?
An entire motor amplifier is in here, and also the encoder function is in here. And there's a 32-bit DSP, so it acts like a PC basically.
So you took all that controlled electronics and power electronics and put it right at the point of the motor in that little puck.
Exactly.
It's about the size of what used to just be the shaft encoder.
Yeah.
Right? Pretty cool. I think that's really cool. And so, Bill, and how did you mentioned you use SolidWorks to fit everything together? To fit
That's right. That's right. We needed to dovetail the electronics. We have a pair of 10-layer boards that come really close together, and the components on those boards had to be nested. So it's a very complex design problem because electrically it has to be right and mechanically it has to be right.
This is really amazing. So, and what happened to the count of the wires by doing this?
We got to a count of 4.
4 wires.
Four wires.
We went from 100 wires to 4. Yeah, just 4 wires. It's just awesome. I mean, you see the robot doing these amazing motions, and then where's all the wires? And there's no more cabinet, right?
Right. Yeah,
there's no motor cabinet.
We used to have 3-phase power, 20 amp lines. So this is a controller.
Oh, right, the power too. This blew me away when Bill told me about the power. So you had, of course, you'd expect 3-phase, 220 3-phase coming in that box.
That's
right?
right.
That was the old way, right?
Yeah.
With the puck, what happened?
Well, with the puck, it also was serendipitous that the invention calls for this to be very simple, and it's got not the amount of electronics that those controllers have. The amount of power that it takes to run a WAM today, which is WAM is the name of our robotic arm, takes 5 9-volt batteries, and that'll run it for 20 minutes.
Yeah. You got that, guys? He can run the robot you saw doing the human-like motions. I've seen it. I've seen it with my own eyes on 5 9-volt batteries. It's unbelievable.